Hi folks, welcome back. So, um, this is the second part of the straight line topic. So we'll just move swiftly on and we'll get equations of lines in two dimensions here. So that one you might be familiar with, y equals mx plus c. X and y, they're embedded, they will appear in the final equation. So m and c, they will just be numbers for us. And so what we have here, information that we would need for this form is the gradient and intercept. Another form that you may have seen, y take away b equals m times x take away a, all in a bracket there. So a and b represent a single point and then the gradient. And sometimes they call that the point slope, where point is the gradient there. So that would be the information you would need in order to use that one. Maybe a less familiar one is this one here, where they're using capital letters here. Ax plus by plus c, that's equals here. So that's called the general form. And please note that the large c there, that does not equate to the small c in the top format, where that would be the y-intercept. Okay, so usually that last one, they tend to use that to get rid of fractions, and you might be heading into the zone of solving simultaneous equations. Okay, let's just go for one here. So now giving you some information, you got a point here, coordinates 15, 3, and it's got a gradient 2 over 5. And they want you to express it in the general form. Alright, so general form, that was that last one, ax plus by plus c is equal to 0. So, but initially, we can only go with the information we have here. So the information we have is one point, the coordinates of, and a gradient. So that's exactly why we're using this format to start with, and hopefully it will lead us to the answer that we can express in general form. So let's just go and put things in here. And in general form, we don't have fractions, so that 2/5 is posing a problem here. So in order to get rid of that, just multiply both sides by 5. The reason we've chosen 5 is because that's the denominator of the fraction, okay, i.e. the gradient of 2/5. So if we multiply through it by 5, I'll get rid of that. But just remember to multiply both sides by 5 here. Okay, so we get 5 times y take away 3 in the bracket on the other side, and 5 times 2/5. That's what we're interested in, getting rid of that in front of the other bracketed term with the x in it. Take away 15. Right, so here that involves cancellation. If you can't cope with that concept, use your calculator. So that leaves you with just 2 in front of the bracket here. So now you get brackets both sides with the numbers on the left hand side, and we're going to distribute that number to both terms inside, i.e. multiply them both. So, right, that's exactly what we're going to do here. Just going to multiply them both. Okay, and bring everything over to the one side. So, yep, multiply them both. Bring everything over to one side because it has to be equal to 0. And I'll put that in the form ax plus by plus c equals 0. That's fine. But you can have it any format you want. If you want to have a positive term at the front, we could have put the 5y there. Usually the x and y would go in the front, or y and x. It doesn't matter. Okay, the most important thing here, it's equal to 0 for both of them, and we'll get rid of the fractions. That's our solution. So again, another similar question here. Again, general form, we'll get two. We've only got 2 points here. Okay, with the coordinates -2, 4 for A and 1, 5 for B. Right, so I'm just going to label these x1, y1, x2, y2. And so I need several things here. So to start with, first thing, well, kind of one of the only things I can calculate here is a gradient. So there's my gradient formula here. I've labelled my numbers up there so they'll know where to go and sit in the formula for the gradient m. So I'll put everything in. Okay, I'm just using little brackets for safety here, so let's tidy up. 5 take 4 is 1, 1 take negative 2, watch that, and that's going to give me a gradient of 1/3. Don't decimalise that, that's nice. So we're getting a gradient of 1/3 here. Right, so I'm now moving on, and because I now have a gradient, and AB represent 1 point, well I had 2 points here, and you can see there, -2, 4, and 1, 5. So I'm just going to select one of those points. I'll probably pick 1, 5 because it doesn't have any negatives in it there. So just in case you're wondering where it's coming from, it doesn't have any negatives. So if you want to use other point, it will still work out. Okay, so let's put things in position. There we go. Things are in position there. And the general form doesn't have the fractions in it, so our fraction a third, to get rid of that, multiply throughout by the bottom part, the denominator, i.e. 3, on both sides. Okay, so we get that there. Right, on the right hand side, it is 1, so it will be absorbed by the x and the minus 1 in the bracket. Okay, so we could get rid of that, but remember on the left, multiply both terms by 3. So we've got that there, and just bring everything over to the left hand side, and you put it in whatever order you want. If you want to have a positive term on the left, that's fine. If you want to have the left or the x on the left hand side so that it reflects the format ax plus by plus c equals 0, that's also fine. Okay, as long as we don't have any fractions and they're both equal to 0, they are equivalent. So that's our answer in general form there. Okay, going for another one here. So again, the coordinates are 2 points. You might spot something at the start here, I don't know. But we'll go for it. I've labelled it x1, y1, x2, y2. There's my gradient. Let's get the numbers in. Oh, be careful, we'll get negatives there. 12 take away 9 is 3. -5 take away -5. Well, that's something take away itself. So on the top, I should have 3, and on the bottom, I should have 0. In the calculator, that says undefined. Because you can't actually divide by 0. So I probably talked about that more at length in class. Um, but that's a little debate you can have with yourself later on. Why we can't divide by 0. Right, because if we brought the 0 up to the left hand side, can you find a number times 0 that gives you something other than 0? If you can you let us know? And it's not -3, okay? Right, so that we can't get an answer just with our setup we're using here. So here, I put in a vertical line there for y. So as soon as our gradient is undefined, well, y, there's a y-axis, its gradient is undefined, but our line, so did you notice what they had in common? The x values were the same. Okay, so if the x values are the same, actually one point will lie directly above the other, so it will be a vertical line. And vertical lines always start with the equation just x equals the x number there. So that's what we're going to have. So finally, x is equal to -5. Right, okay. Here, extracting the gradient will they'll give you an equation in some form, and if it's in a nice form, you'll be able to identify the gradient right away. But they don't usually do that. So here, they're given this equation of a line, 5x plus 3y take away 9 is equal to 0. So that looks as if it's in a general form there. it's not in a form where we can readily take out the gradient, so we have to put it into a form. So y equals mx plus c, that's really the form I think we're heading towards here, because the number in front of x is the gradient, i.e. m. So just rearranging here. So we want to get the y term on its own, everything else over to the right hand side. Okay, so we've got 3y equals some other stuff. So I think we're just going to have to divide both sides by 3. Okay, and the x term and the constant term 9, I've divided both by 3. So I'm just going to tidy up if I can there. The 9 over 3, it's going to come down to 3. But the negative 5 over 3, I can only express that as a fraction. It's going to be overall negative, so I'll draw the negative out the front and level the fraction bar there. So I've got y equals negative 5 thirds times x plus 3. So that looks nice. So the number in front of x, that is our gradient. Okay, so our gradient is negative 5 thirds, or negative 5 over 3. That's us, we've extracted the gradient. But we had to rearrange the original form into the form y equals mx plus c. Just giving you a little chance to read it there. So we'll get an equation here in a certain form, and they're telling you that it passes through a point. They're giving you the coordinates for p, so p has coordinates 4, 10, and another point q. They don't seem to be giving you any information about that. That's probably because you don't need additional information. I think they're just giving you, I'm letting you know there's definitely 2 points, because we need at least 2 points for a straight line. Okay, so let's see, so they want the equation through the point P that we have coordinates which is perpendicular to the line PQ. Okay, so perpendicular at right angles to, so we've seen that in the past, so maybe we'll use the relationship between the gradients of perpendicular lines. Okay, so there's my equation there. I'm just rearranging it here in the form y equals mx plus c probably. Okay, so y is on the left, so maybe swap sides here. Yeah, I've done that. So it's in the form y equals mx plus c. So I'm just going to match up the values in front of the x, because they represent the gradients. So it looks like I've got a 3 there. Right, so that's the gradient of PQ. So I'm using the subscript PQ, so that's the gradient of the line PQ. It's equal to 3. Right, so that means the gradient of the line perpendicular to that, we saw that before. 3 is really 3 over 1. So if we flip 3 over 1, we get 1 over 3. But remember, the gradient for PQ was positive, so we change that to a negative. So we have seen that before. So if in doubt, just go back and have a little look at that there. Right, so we've now got the gradient of the line which is perpendicular. We're going to take that information and just remember it's going through the point P that we have the coordinates of. Right, so here I'm just giving you a little check here. So gradient of one line times the gradient of another, because they're perpendicular, they're equal to negative 1. So I'm just showing you that 3 times negative a third is negative 1 there. So that's just one little check here. Okay, so the equation of our perpendicular line, we know the gradient is negative third now, and we do know the coordinates of the point that it's going through. It's definitely going through the point P, and so that's the format. Y take away B equals M times X take away A in the bracket there. Got that information on the right hand side. Let's put them in there, and a little bit of tidying up here. I've used the negative third to multiply out the bracket on the right hand side, and it depends on the format you want. If you want it in the format y equals mx plus c, then that's fine. So The good thing about this format here, the number in front of x you already know that's the gradient, but the number at its own, the plus 34/3, that's the y-intercept, where the line crosses the y-axis, so it's good to have it in that form. If you didn't want it in that form there, and you wanted rid of the fractions, you could go back and use the general form, so we could take it back to a certain point here, put things in, get rid of the fraction here, 1/3, okay, just multiply both sides by 3. On the right hand side, multiply throughout by the -1 there, and just get everything over to the left hand side. That format looks fine there, or in fact we just left it like that there, because I think that's because x was positive. So if you don't like fractions, that's the format maybe you want to use, or if you're going to go on and use simultaneous equations. Right. That's the second time I've mentioned simultaneous equations. If you're unsure of those, you better go back and check notes from a previous unit. Right, okay, let's move on. Talking about special lines within triangles, there's many. We're only going to look at a few. I'm looking at one called the median. Median may suggest the middle. Depends what topic we have here, but we've got this triangle ABC, and here a median is a line that comes from one of the corners or vertices. We've got 3 vertices, and it goes to the midpoint of the opposite side. So I'm just coming out directly from A, sort of going down to the bottom, and I'm finding the midpoint of BC. I'm calling that the midpoint M. So that there, the line going from A to M, that's actually a median. Right. And like it's saying, it's just one of the medians. Right. So I could come out from B and go over to sort of the middle there. That would be one there. So B going to the midpoint of AC, and I could just pick a little letter there, that would be fine. Or I could go from C over to the midpoint of AB. And what you find is that all 3 medians they meet at one point, and that point there is in the centre where they cross is referred to as a centroid, but we might talk about that later. We'll see if it crops up, but let's just stick to 1 here. Right, so I've got a triangle here, and I've got the coordinates of the vertices and the corners, and okay, so just showing you it there, and find the equation of the median BN. So I can see B up the top there in my picture. So B to N, I don't have an N value. So if I'm coming out from B, it means, so I'm coming out from B, so that means I must be hitting somewhere between A and C, right? So, but it's going to be the midpoint, wherever the midpoint is. So let's see. Let's go and get the midpoint, and they're using the letter N here, so I've just used it. This symbolism here and here, this is telling you that the length going from A to N and from N to C, they are identical in length because N is a midpoint of AC. That's what those little lines. Sometimes you don't, maybe you just use one. Okay, right. So we've now placed N, and we want an equation of the median BN. We've got the coordinates of B, so we're going to have to go and find the coordinates of n. The thing about n, it's the midpoint of AC, and we have the coordinates here. So midpoint, we have the endpoints. We've seen in the past we had something called the midpoint formula, so we could go and use this. So n is between A and C. We have the coordinates here, so we'll go and find n, the midpoint. I'm using x bar, y bar, because that's the average of x and the average of y, the arithmetic average. So let's go and get the midpoint formula. You have seen that before, the averages of x, the averages of y, and because there's 2, that's why we're dividing by 2 here. Let's get the numbers in and just tidy it up there. So that tells you that n, the coordinates of n, is actually 7, 2. Right, where are we heading towards here? Well, we want the equation of the median, b to n. We've now got the coordinates of n. We previously had the coordinates of b. Right, so that's what we're putting down here. You can always refer back to your diagram, and you could always insert the coordinates of n in the diagram if it helps you. I've just put them at the side here because I know that that's my ingredients for the next part here. Right, so I've only got 2 points here. I need the coordinates, so I need the gradient as well. So labeling as usual, get my numbers in. I've got -6 over +2. That's going to be overall negative. So that's my gradient is -3 there. That's fine. So that is the gradient of the line BN. Okay, so in order to work out the equation, I need to use one of those points here, either B being 5,8 or N being 7,2. It doesn't matter. It does not matter one little bit. Right, so you pick one, but definitely the gradient is -3. Pick any one you want. I've highlighted the coordinates of N, right, and I'm going to put them in there. Right, things I've put in there, looks like I'm going to multiply out on the right hand side the terms inside the bracket by -3. Done that. Isolate y. Yep, got that there. So if you think, if you're happy that, so that's the equation of line in the form y equals mx plus c. If you're going back and think, why did he use the coordinates of n and not the coordinates of b? Why don't you go and try that, okay, and put them in and see what equation that you actually get. I'm sure you'll come up with the same equation. Okay. Right, or if you wanted to put it in the general form there, everything over the left hand side. With this one here, we didn't have any fractions anyway, but just make sure it's equal to 0 there. Right, okay, so now an altitude of a triangle. Well, altitude is a line within a triangle here. So an altitude, again, it's going to be a line through one of the corners, the vertices, whatever, a singular being a vertex. So perpendicular at right angles to, so we'll just pick one of these here. So I'm coming directly from Q with a line in it. It's actually at right angles to, we can call it, well, just a line PR. Okay, so we refer to that as an altitude. Right. I just sort of showed you before, we've actually got 3 altitudes. So if I come from P and I'm just trying to put that, does that look like a right angle? Maybe that's not a right angle there. And if I come from R and go up there, that looks like a right angle. And where the 3 altitudes cross, they are coincident at the same point there. And that is not the centroid, it's given another name there. But all three altitudes are coincident within the triangle. Yes, just remember altitude at right angles too. So, uh, okay, again, it's giving you a little triangle there. Have the coordinates of it, and they're probably going to look for an altitude here. Yep, find the equation altitude AD. We'll get 1 point on it, um, A, but we're going to go to D. Right, AD is perpendicular to the line BC or CB. We can go and get the coordinates of the gradient of CB because we do have the coordinates. Once we've got the gradient of CB, that is related to the gradient AD because it's perpendicular to it, because we had the relationship about perpendicular lines and their gradients. So that's what we're going to do there. So because the lines are perpendicular, the product of the gradients, i.e. the multiplication of the gradients, comes up to give you -1 there, unless they're horizontal and vertical lines. So just taking the coordinates of that line in the triangle BC, because D is somewhere along the distance here. So we're going to go for the gradient here. Everything's been labelled, so put things in. So it's 4 over -8. That's going to give us -1/2. Okay, but that's BC. So we want the gradient of the line perpendicular to that there. Right, so just putting that away to the side there. So remember, gradients of perpendicular lines, the product is -1, but 1/2, the quick way to do it is just flip it and change the sign. So 1/2 goes to 2/1, it's just 2, and a negative goes to a positive. So that's why the gradient of AD is equal to 2 here. Right, okay, so now for AD, we've got a point on it, 2, 7, we've now got the new gradient of that line is 2. So let's go for the format where we have the gradient in 1 point, put things in, and multiply out the right hand bracket by 2 here, and maybe isolate 7 there. Right, so that looks okay. Y equals 2x plus 3. So folks, I'm happy with that answer there, and I'm just going to leave it there. Okay, so we've found that altitude there. Right, so bye for now.